Now, composition of functions actually sounds more difficult than what it actually is. Okay? Composition of functions is really just taking one equation and plugging it into another equation. That's all we're talking about here. You've done this before. If you think back to what you did in Algebra 1, there was a time in Algebra 1 where they said y equals 2x plus 3 and x equals y minus 3, and they said solve this system of equations. And one way that you learned to do that was substitution. They said, well, wait a minute, x equals this, so why not take this and plug it into x in the other equation, right? Remember doing that? And you went through and said, all right, so y equals 2 times y minus 3 plus 3. Yes? Yes. Okay. That's a composition of functions. That's it. Both of these original guys are functions. We're just plugging one function into another. All right? Yes?
How would that work? Would it be 2y?
Right, then you'd have to distribute the 2 and solve for y. Yeah. Okay? So that's essentially the idea of what we're doing today with composition of functions. Now, of course, we're not in Algebra 1 anymore, so of course they expect a little more out of us. All right? So we go through, and now we're dealing with functions. We know there's a definition of what a function is. They're not just dealing with any old equation. It's a function. One input gives us one output. Okay? And we have some notation to talk about. And that notation sits right here. Now, obviously, there's another copy of it down below. This little circle that you see, that little circle is just that. It's a little circle. Okay? Don't make that into a dot. It's not a dot. It's a little circle. Furthermore, if your multiplication sign looks like a little circle, you need to start filling that in and make it a dot. Because you've got to have the difference between multiplication and the composition of functions, this little circle. Okay? Because what that means, we read it like it's an of. So you can think of that little O as being of. So we read it as g of f of x. G of f of x. And what I do anytime I see that is right through that circle, I put a parenthesis. And I put another parenthesis out in the back. Because essentially, that's what it's telling us to do, which is right next to it. It says, take this f of x function and plug it into the g of x function. That's what's going on here. They're saying, all right, so you have some g of x function, but rather than the x, we want you to plug in f of x. Okay? You're substituting one function into the other function. Okay? So that's the notation. Now, what's going on here? Well, what's going on is that when you have a composition of functions, looking right here, you first evaluate the inside function. Okay? You first evaluate the f of x. So the f of x has a domain, it has a range. The domain goes into the function, your x values go into the function, it does its magic, and it spits out a range. It spits out y values, right? Those y values then get dumped into the outside function, which is our g of x. And then g of x does its magic and spits out an output. Okay? That's what's happening here. The inside function is getting evaluated first. The outputs of that are then spit into the inputs for our next function. It sounds more complicated than it actually is. All right? Things you have to remember. If you're evaluating these things, what's being evaluated first? The inside function. Okay? Why do we need to know that? Well, we need to know that for domain. Domain purposes. Domain are the x values we can use, right? So, if f of x is being evaluated first, that means the domain that we need to worry about is the f of x domain. Because that's going to be the possible x values that we can plug into this thing. Because that's being evaluated first. And then that's going to spit out y values, which are then plugged back into g, and then split out more y values. Okay? So whenever you're worrying about domain, you want to worry about that inside f of x function. And there's an example we're going to do towards the end here that hopefully will demonstrate that pretty clearly. Okay? All right. So let's see what's going on here. Let's do an example. It sounds more complicated than it is, so let's see what is involved. Okay? So first off, this is a great example of what your homework problems are going to look like. Okay? They're going to ask you to do this. Find g of f of negative 3. So just like yesterday's homework, you need to now give me 3 answers. You need to give me what g of f of x is, just the function itself. You need to give me the domain of that function, and then you need to evaluate it for negative 3. So first thing is first, g of f of 3, of negative 3, excuse me. So that means it's going to be g of f of x. We're dealing with g of f of x. So the inside function is what? F of x. And then what's the outside function?
G of x.
G of x. So what I'm going to do to write this, I'm going to first write down g of x. But don't write the x's, because we're going to substitute in for the x's, right? So g of x is x squared. So that means I have g of something equals something squared. Okay? Well, what are we plugging into g of x? We're plugging in f of x. F of x is x minus 5. So g of f of x equals x minus 5 quantity squared. All we're doing is taking one function and substituting it in for the other function. Or into the other function, not for the other function. Okay? That's all you're doing, taking one, plugging it into the other one. Any questions on that? Okay, well, we're not done here, obviously. We're just setting up the problem. But I want to make sure you see what we're doing before we continue on. Everybody comfortable with what we just did? Cool. So now we want to go ahead and simplify. So therefore we have g of f of x equals, well, x minus 5 squared is x minus 5 times x minus 5, which means we need to FOIL. So x squared minus 5x plus 25. And that gives us x squared minus 10x plus 25. So that is our g of f of x function. All right. Well, we're not done. We've got to find our domain. So to look at the domain, just like we did yesterday, we've got to look back at the original functions. So what is the domain of f of x?
Real numbers.
All real numbers. What is the domain of g of x? All real numbers. So then what do you suppose the domain is going to be for our resultant function here? G of f of x. All real numbers, yeah. If there's no restriction for the first two functions, there should be no restriction for the last one here either. All right? So our domain is all real numbers. Well, now we want to find the solution, the output, for an input of negative 3. So g of f of negative 3 equals negative 3 squared minus 10 times negative 3 plus 25. We're just plugging negative 3 into the function we just found. So what is negative 3 squared? 9. What is negative 10 minus 3? Positive 30 plus 25. So 30 plus 25 is 55. 55 plus 9 is 64. And so that is g of f of x. Okay. Oh, thank you very much. Thank you very much. Yeah, I should do it just like I did at the beginning of that problem. Right? It's g of f of negative 3. Yes, thank you. Okay, looking at this next problem, we want h of g of x. Okay, h of g of x. So looking up at the functions they give us f of x, g of x, and h of x. Well, if we want h of g of x, are we going to use the f of x function? No. No, we're not going to use that. Not in this example anyways, right? So we're going to use h and g. Which one is the outside function? H is the outside function. So I'm going to write h of something equals negative 4 over something plus 3. All right, so now we want to substitute in to h of x. And what are we plugging in? 2x squared, or g of x, right? We're plugging in g of x. G of x is 2x squared. So now, looking at this 2x squared in parentheses, is there anything for me to do there? Can I do anything with 2x squared? No. So those parentheses don't, I'm not multiplying it by anything out there. There's nothing really to do. So I can just drop the parentheses. So I have h of g of x equals negative 4 over 2x squared plus 3. Can I simplify that fraction? Can I factor the denominator? No. So right there is our function. Right there's h of g of x. Okay? All right, well now we've got to find its domain. Now this is the example I was talking about where I want to hopefully show you guys that input-output stuff as far as how we're finding the domain of these things. Okay? Because we need to look back at the domains of our g of x function and our h of x function. So looking at the domain of g of x, what is the domain of g of x?
Every number?
What do we call that?
Real number.
All real numbers is the domain of g of x. What is then the domain of h of x?
All real numbers except for negative 3.
There we go. All real numbers except x cannot equal negative 3.
Why negative 3?
Because negative 3 makes the denominator equal 0.
Okay.
All real numbers except x cannot equal negative 3. Okay, so those are our two domains for our two functions we're working with here. So now we've got to talk about the domain of this guy. Now, looking at this function, all right, so we know that the domain of g of x is all real numbers. The domain of h of x is all real numbers except negative 3. Looking at what we have here, our resultant function, h of g of x, which function gets evaluated first?
The G of X.
The g of x, the inside one gets evaluated first. So therefore, any x values that we're plugging into this has to go into that g of x first. Well, those x values are all real numbers, right? We can plug anything into g of x. Well, then we're like, okay, well, wait a minute. If we can plug anything into that, looking at our h of x function and saying, well, it's all real numbers except for negative 3 as an input into that guy, right? So can this function g of x, can it ever give us negative 3 as an output? When we plug numbers into here, all real numbers, when we plug all real numbers into g of x, can it ever give us an output of negative 3?
Yeah, possible.
How is it possible? What are you thinking?
Well, because all real numbers, like, is it possible for the rule, or is it possible because of...
I'm actually asking, is it possible? Can you plug a number into g of x and get negative 3 as an output?
Probably not because it's squared.
There you go. We have an x squared right there. We have an x squared right there. So if you plug in a positive number squared is another positive number times a positive number too. So it's all positive, right? If you plug in 0, you're going to get 0. If you plug in a negative number, you're going to square it, making it positive, and then multiply it by a positive number, making it positive. There is no way to get negative 3 as an output unless we start talking about imaginary numbers, which we don't. We're not talking about imaginary numbers. We're dealing with real numbers. Okay? So does everybody see how we can never get -3 there?
Yes.
Okay, so that then means that any output of this, let's talk about range for a moment. Even though we don't have to list the range, let's talk about the range. The output of this function is going to be all y values greater than or equal to 0. Right? Because you can never have a negative output here. Hello? Okay. So since we're only dealing with 0 or positive numbers as an output, when we plug it into our function here, or even into the function here, do we have any problems with that? Are you sure?
Okay, sure, yeah.
Okay, sure, yeah.
Because if I plug in a 0, is that okay?
Yeah.
If I plug in a positive number, is that okay?
Yeah.
Yeah. There is no output from this guy, from the g of x, that's going to give us any kind of problems with the h of x. So that means the domain of h of g of x is all real numbers. Which brings me back to what I told you guys when we first introduced this concept 20 minutes ago. Not even 20 minutes ago, 7 minutes ago. Is because I said the only domain we need to worry about is the domain of the function that is on the inside, the one that's being evaluated first. That domain we worry about. And look what happened. After we went through the whole input, output thing again with this function, we still ended up with a domain of all real numbers, the same thing that g of x was. Okay? That's the idea. The domain of your resultant function here is going to be the same as that domain of the input function. The g of x, the inside guy. Okay?